Into confusion day, which is okay. Up to this point, simplifying rational expressions, multiplying rational expressions, dividing rational expressions. They had their own little rules of factoring and canceling like factors top to bottom. And then there was adding and subtracting rational expressions where you needed to get a common denominator. So the two topics I'm going to cover today, 6.3, 6.4, they're very interrelated to each other. But one's an expression and the other one's an equation, but you pretty much do them about the same way. And the danger is you're going to want to take those techniques and bring them back to adding and subtracting or multiplying and dividing, and it will mess you up. So you got to be really clear. When you're multiplying, you have to follow those rules. When you're dividing, you have to follow those rules. When you are adding and subtracting, you have to follow those rules on time. So, today is complex fractions and rational equations. And the technique for both of them is very, very similar. So let's deal with complex fractions first. And technically, we already dealt with one type, but it was very simplistic type. Let me just give you an example. If you do anything that's like 2/3 divided by 4/5. This is considered a complex fraction because it has fractions within a fraction. In other words, you have to look at this as 2/3, the numeral 2/3, well, the value 2/3 above the value 4/5. So we have fractions within fractions. Now, anytime you have more than one division sign in an expression, it will be what's considered a complex fraction. So how do we simplify this expression? LCD. Nope.
Multiply by the reciprocal.
Multiply by the reciprocal of the denominator. So this turns into 2/3 from the top times 5/4 in the bottom. Now our technique, not number technique, but algebraic technique, requires you to factor everything. So this becomes 2 times 5 and write it as a single fraction. 3 times 2 times 2. So the only thing that's going to cancel is what? The 2's, and when you cancel them, you replace it with a 1. So what's left behind is 5/6. So this is considered a complex fraction, even though it really doesn't fall under what I think of as a complex fraction. It really is one. All right, so how hard can these get? Yeah. 1/2 minus 2/3 divided by 3/4 plus 5/6. This is technically the ugliest I can make it. With numbers.
LCD, then to the reciprocal?
Yeah, we could do that. Get the common denominator for the top, add them together. Get the common denominator for the bottom, add them together, and see what happens. All right, so common denominator for the top is going to be 6. So I'm going to multiply top and bottom over here by?
6.
No.
By 3.
By 3 to make the bottom 6. But whatever you do to the bottom, you have to do to the top. The other one is missing a 2, so you do it top and bottom. The bottom, how do I get an LCD between 4 and 6?
12.
It's going to be 12, so the 4 is going to have to get multiplied by 3, top and bottom, and the 6 is going to have to get multiplied by 2, top and bottom. That's the important thing with fractions. Whatever you do to the bottom, you have to do the exact same thing to the top if you're adding in pieces. All right, so this becomes, let's see, 3/6 minus 4/6 divided by 9/12. 9 plus 10/12. Okay. Then what?
Reciprocal?
No, not yet. You can't. The reciprocal thing
Oh,
only
you're
works if you get rid of the
already
addition.
ahead.
Oh, you're one step ahead of me. All right. The top is equal to negative 1/6. The bottom is equal to 19/12, and then you multiply by the reciprocal. So this is negative 1/6 times 12/19. Now let's do a little shorthand here. 6 goes into 6 once, 6 goes into 12 twice. So the final answer is
Was it 2/19?
negative
Negative 2.
2/19. Yay! All of that just to get to the answer. Getting a common denominator for the top, getting a common denominator for the bottom. combining your denominators and then multiplying by the reciprocal. That just seems a little bit way too long. There's got to be a better way of doing this. So the better way of doing this, 1/2 minus 2/3 divided by 3/4 plus 5/6. The better way of doing this is to realize that you have a number on the top and a number on the bottom. You know, just look at it as one big ugly fraction. And the trick is this. Find a number that 2 will go into it, 3 will go into it, 6 will go into it, 4 go into it. In other words, what's the common denominator between all of the numbers? 12. So what I can do is, I can take the entire top and multiply it by 12. If I multiply the top by 12, I got to multiply the bottom by 12. Does that change the value of the fraction? No, that's the beauty of it. And what happens is, we'll get to this answer in about 2 steps, rather than all these little baby steps in between. So all we have to do is distribute. 1/2 times 12. 6. It's going to be minus. 3 goes into 12. This is the easiest way to do it. 3 goes into 12, 4. 4 times 2 is 8. Over, and then distribute this guy through. 4 goes into 12. 3 times 3 is? 9. So you get 9 here. When you hit this one, 6 goes into 12. 2 times 5 is? 6 minus 8? -2. 9 plus 10? And we've skipped a ton of steps. So it's a nice little technique. So when you're dealing with a complex fraction, the trick is to multiply top and bottom by the common denominator of every fraction. So complex fraction, multiply pretty much everything by common denominator. Because technically that's what we did. We multiplied 1/2, 2/3, 3/4, and 5/6 by just 12. So another way of doing this would just be writing times 12 next to each one of them, if you wish. Of course, that's not how I'm going to make them look. You know, they're going to look something like, 4 plus 2 over x over x, 1 over x squared minus 3. You know, this kind of complex fraction. Variables in there. All right. What's the common denominator?
3.
Nope.
1.
No, we don't know what it is.
Nope.
Oh, it's x squared.
It's only x squared. This 3 and this 4 are whole numbers. What's underneath each of them? 1. It doesn't count for common denominator. So the only denominators are x and x squared. So the only thing you have to multiply everybody by is x squared. So I'm going to multiply every single term, which is technically multiplying both top and bottom by x squared. All right, 4 times x squared is?
4x squared.
4x squared plus 2 over x times x squared.
2x.
It's going to be 2x. You're going to lose a factor of x. So you're left with 2x over 1 over x squared times x squared. 1 minus, well, 3x squared. And you're done. That's it. Yay! So if you have to, write the 4 over 1, write the 3 over 1 so you can see the denominators of each one of the fractions. Best way to do it. Because a lot of people will take that 4 and 3 and include it in the common denominator, and it shouldn't be. Worse than that. 4 over x minus 3 over x plus 1 over 1 plus 5 over x squared plus x. Just making up some junk here. What's the common denominator?
X squared plus x.
X squared plus x. If you factor it, it's x times x plus 1. So we're going to multiply everything by, well, I'm going to write it as x times x plus 1, the factored form of it. That way we can see which factor goes away and which one stays around after it's gone. So we'll multiply every single term by x times x plus 1. Don't forget any of them. If there are 4 terms top to bottom, you have to multiply every single one of them. You can't just leave one off just because you feel like it. So this one also gets the x and the x plus 1. All right, when you multiply that first one, what happens? This one here. What happens?
Cancel one of the X's out.
The x's are going to cancel because one's in the bottom and the other one's in the top. What you're left with is 4 times the quantity
4x plus 1.
x plus 1. Write it as 4 times the quantity of x plus 1. If you try to do it in your head, you're going to make the mistake of a sign eventually. This one over here, what's going away?
X
The
plus
x
1.
plus 1s are going away. If you want to, you can sit there and cancel them out.
Negative 12.
What's left is minus 3x over, anything going to cancel for this 1? Nope. So we're going to just get x times x plus 1. We'll distribute it later. And over here, what happens? Well, what's x squared plus x equal to? This is x times x plus 1. What happens to the factors then?
Squares.
They cancel out completely. Because one's on the top and the other one's on the bottom. And we're left with plus 5. This is x plus 1. This is x plus 1. One's in the top, one's in the bottom. When you multiply by something, it's automatically going into the top. Yeah, because x squared plus x factors into x and x plus 1. Remember, greatest common factor. What's the greatest common factor is? X. When you kick it out, you're left with an x plus 1. So they both cancel. And then you're left with this factor that's kind of just sitting around on the top. Don't forget him. So you're left with 5. And then simplify. Distribute the 4. Did I do it correctly? Yeah. And then distribute the x. So you get x squared plus x plus 5. Now the bottom you can't do anything with, but the top you can simplify a little bit. 4x minus 3x? What property? 4x minus 3x.
Commutative.
Commutative property first.
Additive.
How do you add 4x minus 3x? Distributive property. Remember that final's coming eventually. So we get x plus 4 over x squared plus x plus 5. Now, it is possible that if you could factor the bottom and it factors into something with x plus 4 that they will cancel, but it's very, very rare. That's not too bad, right? Well, we could do it the other way, which is get a common denominator for the top, get a common denominator. I mean, if you get stuck, that's the way to go. If you forget this idea of multiply everybody by a common denominator, get a common denominator for the top, get a common denominator for the bottom, it goes a long way. All right, let's see how hard they get it in here. That was not too bad. Let's try this. Is number 12.
What page are you on?
This is 327. This is probably as bad as it'll get. 5 over 2x plus 8 plus 3 halves all over 3 over x squared minus 16 plus 1 over x plus 4. The same goal as adding and subtracting fractions. You want to factor every denominator that you see. So, can you factor 2x plus 8?
Yeah.
So this becomes 5 over 2 times the quantity x plus 4. You can't do much with the 3 halves. Over here, you get 3 over x squared minus 16, which could be written as 3 over
X plus.
I don't care which
X
one.
plus 4, X minus 4.
Sure, x plus 4, x minus 4, or vice versa, it doesn't matter. Alright, and then finally that last one we can't do much with, 1 over x plus 4. It's just a linear factor. Now, what is the common denominator?
2. X
A
plus
2.
4, X minus 4.
An x plus 4 and
X
and x minus 4. So I'm going to do this without writing it all over the place. I'm just going to put it over here. So it's 2 x plus 4, x minus 4. And we're going to distribute it top and bottom. Sometimes writing it by every single term is nearly impossible, so this is the other option. And then just distribute it. Here you have to keep what factors are going away in your head. You can't just cancel them out, because if you cancel them out, they have to reappear for the next one. All right, so what goes away when it hits the 5 over 2x plus 4?
2 and x plus 4.
So 2 and the x plus 4 are gone, and you're left with 5 and
X minus 4.
x minus 4. So we'll leave behind a 5 times the quantity x minus 4. Okay. Realize when I say the quantity, it really represents parentheses, a grouping type way of language. All right, over here, when it hits this second fraction, what happens?
2's cancel out.
Only the 2's cancel out. So you're left with a positive 3, x plus 4, x minus 4. All over
6.
when this one hits the first one, what goes away?
Everything but 2.
Everything but 2 and
3.
3, so we get 6. Plus, and when it hits the second one,
X plus 4.
the x plus 4's are gone, so the only things left are 1, 2, and x minus 4. So we get 2 times the quantity, x minus 4. Woohoo. This is getting messy. Let's bring it up here. Okay. All right, distribute. 5x minus 20. 5x minus 20. Now this right here, the x plus 4 and x minus 4, we know that multiplies together to give us
X squared minus 16.
x squared minus 16. So then we just have to multiply that by 3. So we're going to get 3x squared. What's 16 times 3?
48.
48. So it'll be negative 48? Yeah. Negative 48. Over, and the bottom, that's one. It's a little bit easier. You got a 6, you have a 2x, you have a minus 8. Hey, can I take 8 and divide it into 48?
Mm-hmm.
Who said mm-hmm? I hope you said
Yeah, I did.
No.
Why can't we cancel out the x minus 4s?
The same reason that you can't divide 8 into 48. When's the only time you can cancel? There's only one option when you can cancel top to bottom. When there's no pluses and there's no minuses. There's a plus here, there's a plus here. You can't touch it. Over here, you can't take out the 8s because they both have minuses in front of it. Plus, there's those positives, and then they're separate terms. They have to be multiplied together. All right, so the only thing I can do to the top, get it in order, combine like terms. 3x squared plus 5x minus 68 all over 2x minus 2. If you can, always try to force that minus sign in between two terms rather than sticking it up front. And there you are. Nice answer. What can x not equal?
Say what? 2x minus 2, how you get that?
2x.
Mm-hmm.
6 minus 8.
Oh, okay. Okay, combine like
What can x not equal here?
Mm-hmm.
What can x not equal here?
0.
0? No, it can equal 0. You can get negative 2 in the bottom.
You asked, I just gave an answer.
What can the denominator not be?
2x minus
Yeah, but what can it not be? What can you not divide by?
2. Negative 2?
What can you not divide by?
We don't know.
I can write 5 over 7. That's legal, right? I can write 5 over 3. That's legal, right? Can I write 5 over 0? Why? You can't divide by 0. So what can x not equal over here? No, it can be, x can be 0, because 2 times 0 is 0. 0 minus 2 is negative 2. You're not dividing by 0. We did this earlier. It's called domain.
Negative 2.
No,
It's positive 2.
it's what?
1.
1.
I said 1.
I didn't hear
Yeah,
you,
she did
mumbler.
say a long time ago.
Oh, I didn't hear
Yeah,
you.
she said.
Okay, I have a question.
It's probably because you said it.
I have a question.
Go for it.
Please step back. Right there, when you,
I like when you said right there.
okay, when you distributed the, 2x, 2 times 1x plus 4 into the 3 over
Okay.
there.
Here.
Yeah.
Okay.
You multiplied 3 times 2, right?
Yes.
Wouldn't the x plus 4 cancel out?
X
You
plus
would
4 and the x minus 4. See, this one has x plus 4 and x minus 4 in the bottom. This is x plus 4, x minus 4 in the top. They're identical, so they're going to cancel completely. Because then you're saying this whole thing divided by that whole thing is just 1. And then you're just left with a 2 times 3. Yeah, keep it simple. If you have to, put these things over 1. So you realize that it's in the top automatically. But technically, when you multiply by a number, it automatically goes into the top. Unless it's a fraction. All right, so that is complex fractions. That's not horrible.
All right, now we have to do rational equations, which are not cool.
Rational equations aren't horrible. Let's start off with some boring ones. We've done this before. Number 4 on page 333. 333. So this is 6-4. Five over 4x plus 2 equals 1 over x. What can x not equal?
1,
1's fine.
0.
0. This one you can say x cannot equal 0 because 1 over 0 is not going to work, and 5 over 4 times 0 will not work either. Can't divide by 0. How do we solve this equation? Well, we solve it like I've taught you before. What did I teach you to do before?
Find the common denominator.
Find the common denominator and
Factor.
multiply everybody by it. So the technique to solve that equation is the same technique that we're using over here with complex fractions. It's just that instead of having something over something, we have something equal to something, and they all have fractions in it. So the technique is the same, just be really careful when you use these techniques. They don't work for all situations. Multiplying top and bottom by the common denominator only works for complex fractions. Here we're going to multiply both sides by the common denominator. That only works if it's a equation. You can't use it for adding and subtracting fractions. You cannot use it for multiplying and dividing fractions. It only works for these two cases. So I'm going to multiply everybody by 4x. Both entire sides by 4x. Where to stick it here? And then distribute it. What happens when I multiply 4x times 5 over 4x?
5
You just get 5. What happens when I multiply 4x times positive 2?
plus 8x.
Plus 8x. And over here, x goes into x once, and you're left with 4. I heard it. I heard a 3 someplace. Not good. All right, how do I solve for x?
Subtract 5.
Subtract the 5 from both sides, so we get 8x is equal to
-1.
-1.
Divided by 8.
And divide by 8, and we're going to get x equals
-1/8.
-1/8. And there's our answer. As long as x doesn't equal 0, we're perfectly safe. Perfectly safe. All right, that was easy.
Pretty close.
How about... this one's not too bad. Number 6. 4 over 3x minus 1 plus 1 over 2x equals 3 over 2x. I could make one of these up off the top of my head, but the answer would be horrid. Yeah, it'd be like -17/35 or something silly like that. Right. What do I do? Well, it's an equation, and it has fractions. So you multiply by
LCD.
the LCD, which is
3x minus 1, 2x.
3x minus 1 times 2x. Reverse the order, and it looks prettier. Now, if I want to shorthand this, I'm going to take the entire thing. This is technically not legal, because you can't distribute over an equal sign, but since you're multiplying both sides of the same thing, you can kind of think of it as, I'm going to distribute over the entire equation 2x times 3x minus 1. And technically, it takes care of multiplying both sides. Multiplying both sides by the same thing. So, When I multiply this mess times that first term, 4 over 3x minus 1, what happens? 3x minus 1 is canceled, and you're left with a 4 and 2x, which is 8x. That's easy. 8x. Plus, when I distribute it to that term, 2x cancels, and we're left with a 1 times 3x minus 1. Now, should I keep it in parentheses, or can I drop it? When would I want to keep it in parentheses? If this sign is minus. Once this is minus, you've got to keep those parentheses. But since it's plus and that's a 1, we can drop it. 3x minus 1. We also want to keep it if it's like 2, 3, something like that. All right, equals. Don't forget the equal sign. This is an equation, not an expression. What happens when we distribute to this term on the right-hand side? 2x cancels, and we're left with 3 times the quantity, 3x minus 1. Better known as 9x minus 3. Let's wait for someone to say 9x minus 9. That always happens. All right, what do I do first?
Combine like terms.
Combine like terms. Get the 8x and the 3x together before you do anything. So this is 11x minus 1 equals 9x minus 3. Subtract the 9x over, you get 2x. Minus 1 is equal to negative 3.
Add the 1.
We'll bring it up here. Add the 1, so we get 2x is equal to negative 2. Therefore, x is equal to negative 1. Now, here's our danger. We'll get down here, we'll have this nice answer. Sometimes if you go back to the beginning and plug it in, what'll happen is you'll get a 0 in the bottom. And it can't be 0 in the bottom. So we might get an answer for this, but then we have to realize that it doesn't work in the original equation. Those will show up every once in a while. I have to find one for you. In this case, though, negative 1 is perfectly safe. Because if I plug it in here, it's not going to make a 0. If I plug it into those two, it's also not going to make a 0 in the denominator. So totally our answer. Why would it be possible? Well, here's the danger. If the answer was, well, let's say we got down to the end and x is equal to 0. If x is equal to 0, what did I multiply everything by? If x is equal to 0, here I multiplied by 0, and that kills everything, and you eventually just get 0 equals 0. So the equation makes sense, it's just the original expression doesn't. So you just got to be a little cautious. See if I can find one. There's one. Number 22. Three halves plus 2 over 2z minus 8. Yes, that's a z. Equals 1 over z minus 4. I write my z's with a slash because my 2's look like z's. Keep looking at the devil back there. She's making me nervous. I know I signed that contract, but I don't want to forget. Okay. So what should I do first?
Factor out the 2z minus 8.
2z minus 8, what comes out?
2.
The 2 left behind?
Z minus 4.
Z minus 4, which is nice because that's what this one is over here. Okay. Common denominator for the whole equation? Get the language in there too. Times 2 times the quantity z minus 4. What's that? This one has a factor of 2. Right? He has a factor of 2. So obviously the part of the common denominator is going to have a 2 in it because he's missing it. Right? If you're going to add them all together, you'd put a 2 here, and a 2 there. He's missing z minus 4. So you put 1 here. He already has one, and he already has one. So the common denominator is 2z minus 4. So you do, same idea as getting a common denominator. You get all the factors that you're missing together. Let's see what you get. All right, so if we distribute way over here to 3 halves, what goes away?
2.
The 2. You're left with that factor of 3 and the quantity of z minus 4, plus what happens when we get that term? The 2 and z minus 4 are going to cancel out, and you're left with a factor of 2 from the top, so don't forget him, equals, what happens when we get this guy? The z minus 4s are going to cancel, and you're left with 2 times 1, better known as 2. A nice simple linear equation. And distribute the 3, so you get 3z minus 12 plus 2 equals 2. All right, now what?
Combine like terms.
Combine like terms, 3z minus 10 is equal to 2.
Add 10 to both sides.
3z is equal to 12, right? And z is equal to 4. And if you leave that on your test paper, the whole problem is wrong. Why? Well, because if I go back to the beginning and I say, well, here are my denominators, what can z not equal?
0.
No, the denominator cannot equal 0. What can this not equal? Cannot equal 4. Because if I plug in 4 for z, I'm going to get 4 minus 4, which is, and I have 0 in the denominator. So this is not a solution. Your final solution is either this or no solution. Because 4 makes division by 0 in our original equation. So we can't have an answer because I was here the whole time, Mr. Flores. Whose watch? Someone in China. Ugh. Do they get uglier? Not really. How bad did we get? 24 is the worst one I can see on the page. One over x minus 1 minus 2x plus 1 over the 2x squared plus 5x minus 7 is equal to 6 over 2x plus 7. Technically, what you should do before you even start solving this is to find out what x can't be. Because once you get down to the end, you're like, oh, z equals 4, and you go on to the next problem. Because that's what you're used to. You get to an answer and you just kind of go on. With these, you have to be a little bit more careful because these x's are in the denominator. So over here, we're looking at x plus 1. What does that tell me about what x can't equal? It can't equal 1. So off to the side, I'm going to write x definitely cannot equal 1. What about this 2x plus 7? How do you find out when it's equal to 0? Set it equal to 0. So go off to the side, 2x plus 7, set it equal to 0, 2x equals negative 7, therefore x is equal to negative 7 halves, and we definitely don't want x equaling this, so if my answer turns out to be negative or positive 1 or negative 7 halves, it can't be part of my answer, because that creates a 0 in the denominator. Now, here's my guess. My guess at about 2x squared plus 5x minus 7, I guess that it factors into x minus 1 and 2x plus 7, because if it doesn't, this thing turns into a horrid problem. But let's make sure that it does. So off to the side, a little practice in factoring. 2x squared plus 5x minus 7. How do I factor it?
7 and 2 is 14.
7 and 2 is 14. Factor 14 is subtracted from 5.
Positive 7 minus 2.
Huh?
Positive 7 minus 2.
7 and 2, so we get 2. So let's see here. 2x squared, 7x minus 2x minus 7. And GCF in the first two is? X left behind is?
2x plus 7.
2x plus 7. GCF in the second two?
Negative 1.
Negative 1 and left behind?
2x plus 7.
2x plus 7. And therefore, when we pull out the 2x plus 7, we're left behind with an x minus 1. So this guaranteed factors into x minus 1 and 2x plus 7. kind of like the way I thought it would. It's nice to verify it. So what's the common denominator here that I'm going to multiply everybody by?
X minus 1, 2x plus 7.
X minus 1 and 2x plus 7. Let's see if we can do this in our heads. Ready? I'm going to multiply everybody by these two factors. So when I multiply everybody by these two factors, what happens with the first term? The x minus 1s are going to go away. And you're going to get 1 times 2x plus 7, better known as 2x plus 7. Minus. Now what should happen right after that minus sign? Parentheses. So that minus sign gets distributed properly. Now, when x minus 1, 2x plus 7 runs into x minus 1 and 2x plus 7 in the top, because you have to imagine that this in the bottom is also up here in the top, what's going to happen to these two?
Cancel out.
They're going to cancel out. What are you left with?
X minus 1.
Mm-mm. They both cancel out. They're both there.
Oh, is it 1?
You're going to have these two factors up here.
1.
You're going to get 2x plus 1. Because they're going to cancel out and you're left with whatever's in the top. Equals. When these two factors over here run into 2x plus 7 in the bottom, what goes away? The 2x plus 7. What's left? 6 times x minus 1. So you get this nice linear equation. They're nice when they're simple factors grouped in parentheses. It's a little easier to think of mentally. When they start becoming 2 times z minus 4 or 2 times x times z, things like that where they get a little messier, it's better to write them out. All right, over here, distribute the negative. 2x plus 7 minus 2x minus 1 equals 6x minus 6. What happens to the 2x's over here? That's weird. And 7 minus 1? 6. So we get 6 equals 6x minus 6. Oh, 6, 6, 6. On Halloween, we'll know. Y'all know that's not in the Bible, right? Really. Numerology was created in 800, 900, 1200, somewhere around there back in. And numerology was you added up all the letters of your name, you related your letters to numbers, and they would add them all up and they'd come up with numbers and they were supposed to tell you something. It's kind of like horoscopes. So if they took Yahweh, which is the Jewish name for God, and they added up all his letters, it came out to be 777. And when they took Lucifer and added up all his letters, his turned out to be 666. And from then on, bad was 666 and good was 777. Weird, isn't it? Add 6, I know. Little side story. It's Halloween. So you get 12 equals 6x, therefore x is equal to? 2. Is it a safe answer?
Yes.
Yes, because it is not in my little list up here. So we're perfectly fine saying, sure, x equals 2 is a fine solution to this equation. Yay! That wasn't bad. What time is it? Ooh, we can actually go a little further. Why not?
Because Fridays are off. We need to push hard in here.
Fun.
Where's the candy?
Fun. Alright, so let me make you do one. Go back to page 327.
Can't make you do it.
I can make you do lots.
Not possible.
I told you we've already really covered these. I'm just adding on a few things. Oh, let's keep it easy for a second. Number 8. 1 over 3y plus 1 over 6y all over 1 over 2y plus 3 over 4y. Oh, shoot. Forgot to clear the screen over here.
It's the same book this ain't the same book next semester, or for the regular algebra, is it?
What's that?
The college algebra is a different book, right?
Yeah, it's a different book. It's a hardcover, first of all, which is nice. Now, are we going to get y equals something on this one? Please don't force it. I've seen people go, hey, y equals 3. And I'm like, where'd you get the equal sign? They make it up as they go, so be careful. Go ahead. This is yours, not mine. Let's see if you were paying attention. Or if you were here. Hey. I'll retract. Two-fifths?
Looks like that.
So let's see, multiply everything by,
Why did you do
12
that?
Y.
multiply what?
Why you act like mine was wrong?
I didn't remember what anybody else, I thought it was 2/3, because someone has messy handwriting.
12 Y.
So multiply everybody by,
12.
mark it on the board. 12y. 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 So when I distribute it through, 3y goes into 12y, 4. 6y goes into 12y, 2. 2y goes into 12y, and 4y goes into 12y. You get 9. I didn't understand why people had y's on their paper at the end. Seriously, I mean, if you did that, there are no,
All the Y's cancel.
all the y's cancel. So I didn't understand how did you? Ooh, that'd be messy. So you get 4 plus 2 is 6, and 6 plus 9 is, they both have a common factor of 3, so 2/5. Yeah, multiply by the entire common factor. Don't leave pieces off. All right, let's try an uglier one. What's uglier? Ooh, this page. Number 18. I don't have that page. I'll write it down for you just in case. We're 18. 2 over y plus 3 plus 1 over 1/3 minus 2 over y plus 3. Hold on to your selves in there.
And my grades from
Contracts with bloody signatures. Ready? Cool. You ready? You done? Are you done?
That means
She didn't answer.
the
Good. What's the common denominator?
3 and Y plus 3.
3 from over here, and y plus 3 from here and here. So you multiply everybody by 3 and the quantity y plus 3. Make sure you distribute to every single term.
Who was finished? Who was done?
I was.
It must
I
be
left a
something
number
else.
out.
You left a number out. And we don't like you. Throw you away. What does that hint help? We're back to work.
I'm sorry.
Show them the first step and they start to work. You should have known the first step. Multiply by the common denominator. You left a 3 out?
Yeah.
Did you end up with fractions in all your mess afterwards? Okay. Yeah, made a mess. Once you start doing that, you know that you didn't pick the right LCD. All right, so the first one gets hit by 3 times y plus 3. What goes away?
5 plus 3,
The y plus 3. You're left with 2 from up top
6.
and the 3 from over here, so you get 6. Plus, nothing cancels. This is just 1. So 1 times this is, well, that, which is 3y plus 9. I'm going to distribute it out. Over 1/3 times 3 times y plus 3. What goes away? The 3's, and you're left with y plus 3. I can take it out of the parentheses because there's nothing in front of it, and it's not being multiplied by anything, including -1. Here we have a minus, so the next symbol I'm going to write is a parentheses, just so in case there's anything over here to distribute it over. When the y plus 3's run into each other, they cancel, and the only thing you're left with is 2 times, which is nice, simple 6. It's not a wasted parentheses. Trust me, that's where most mistakes happen. Combine the like terms in the top, and we'll get 3y plus 15 over y minus 3. Now, you can pull out a 3 out of the top, and it leaves behind a y plus 5, but is it useful? No. Now, if I factored it out, it left me with a y minus 3, I'd be happy because then I could cancel a little bit more. But in this case, you could leave it like this, or you can pull the 3 out, I don't care. You can write it as 3 times the quantity, y plus 5, that'll be fine. All right, homework. It is time, right?
We're not finished.
We're not finished. Oh, you want to keep going?
Yeah,
Happy
but
Halloween.
homework.
Homework. Where? In 6.3, do all the practice problems. In 6.4, do all the practice problems. And then on page 329, do all of it. Oh, on 329? 14. And 329 is the kind of review over the first 3 sections. So you're simplifying, you're multiplying, you're dividing, you're adding and subtracting, and then you're doing complex fractions. But don't forget to do the practice problems in 6.3 and 6.4. I'll come back with more homework on those later because those are where people get a little wishy-washy.
When can I retake my test?
Retest today,
Yeah.
1 o'clock. Anybody else? Did you do your corrections?
I'm going to right now.
I'm going to go do them right now. There we go. Wait till